How do you manage residual stress in welded components? Imagine a metal piece that has just been welded together. Even after the sparks fade, tiny stresses remain as locked inside, like hidden tension waiting to cause problems. That's residual stress. Managing it is key to making sure your welded parts stay strong and last long. Residual stresses come from uneven heating and cooling during welding. When metal heats up, it expands. As it cools, it contracts. If this happens unevenly, it creates internal stresses. Metal can also change phases during welding, which adds to the stress. Mechanical constraints from fixtures or the shape of the joint can make things worse. To control these stresses, engineers start by understanding where they come from. They look at how the metal heats and cools, and how the weld design influences stress buildup. Good design is crucial. Adjusting welding speed, heat input, and electrode type helps reduce excessive heat and thermal gradients. For example, using a lower heat input or a faster welding speed can limit the amount of heat that spreads into the metal. Proper joint design also matters. Using the right fit-up and avoiding sharp corners can lower stress concentrations. Fixtures are used to hold parts steady during welding, preventing unwanted distortion. Preheating the base metal before welding is another smart move. It makes the metal expand more evenly and reduces the thermal differences that cause stress. After welding, post-weld heat treatment is often performed. This involves heating the welded component to a specific temperature and then cooling it slowly. This process relaxes the internal stresses and makes the part more stable. Mechanical methods like ultrasonic impact treatment or ultrasonic peening are also effective. These techniques apply mechanical energy to the surface, creating compressive stresses that counteract the tensile stresses inside. Shot peening is similar, where small spherical media are blasted onto the surface to induce beneficial compressive stresses. Vibratory stress relief uses controlled vibrations to help redistribute residual stresses evenly. Measuring residual stresses accurately is essential. Techniques like X-ray diffraction and ultrasonic testing help determine how much stress remains after welding. This information guides further treatments. Computational tools like finite element analysis simulate how stresses develop during welding. These models help engineers plan better welds and treatments to minimize harmful residual stresses. In industries like pipeline manufacturing, pressure vessels, and railway components, managing residual stress is vital. For example, ultrasonic peening has been used to extend the fatigue life of high-strength steel welds. Laser shock peening introduces deep compressive stresses on the surface, improving fatigue resistance in welded rails. To sum up, controlling residual stress involves a mix of careful process planning, thermal treatments, mechanical stress relief methods, and precise measurement. Combining these strategies ensures that welded parts perform safely and last longer in their respective applications.